A violent solar storm that swept across Earth on Monday, February 27, prompted SpaceX to postpone a Starlink launch from Florida and momentarily halted operations on 3 Canadian oil rigs because GPS signals were too unreliable. SpaceX has been working with NOAA since a catastrophe in February last year when the business lost a batch of 40 satellites after flying them directly into a rather minor geomagnetic storm. As massive numbers of charged solar particles reach our planet, their interactions with the upper atmosphere cause the atmosphere to expand. As this happens, the density of gases at higher altitudes rises, causing spacecraft to feel the additional drag. When SpaceX launches Starlink vessels at very low altitudes and then uses the satellite's onboard engine to increase its orbit, the added drag proved too much for the ill-fated spacecraft. Since that occurrence in 2022, the business has not only paid closer attention to space weather forecasts but has also provided data from Starlink's onboard sensors to assist NOAA to improve its space weather forecasting models. The G3 storm that prompted the launch delay on Monday was triggered by a mix of events. Streams of rapid solar wind have been streaming toward Earth in recent days from a so-called coronal hole, which is effectively an opening in the Sun's magnetic field. Furthermore, 2 coronal mass ejections (CMEs), or massive blasts of solar plasma, originated from an active area, or sunspot, during the weekend and arrived on Earth in short succession on Sunday and Monday, February 26 and 27. The solar storm triggered a feast of aurora displays over North America and Europe, with sightings recorded as far away as South Dakota, Wisconsin, and California. Committed aurora chasers were also able to capture the arrival of the southern polar lights above Perth, Australia's westernmost major city. The stronger G4 and G5 storms have not yet happened during this cycle. While G4s are still rather common, with up to 100 impacting Earth per solar cycle, the most severe G5s occur just around 4 times per cycle. G5 storms have the potential to produce extensive power outages and potentially destroy power transformers. Spacecraft operators may lose track of their satellites during such intense storms because the swollen atmosphere affects satellite trajectories. Scientists warn that the environment around Earth, with fast-growing numbers of active satellites as well as particles of space debris, might become very susceptible to a G5 storm. The loss of control over functional satellites, as well as a lack of information about the positions of pieces of space junk, might lead to accidents and accelerate the proliferation of trash in near-Earth orbit.